This video is for Math 0232-1332 as we do the first review. Wait, let me go here first. Here it is. Okay. So we did the three sections of chapter 1, and there were 4 sections of chapter 2, and there were a couple of the 0232 homeworks as well. And then they always throw some knowledge checks in every so often, but review exam 1, and then you'll take exam 1 on October 8th or 9th. That's a Wednesday or a Thursday. The test has 20 questions, and they estimate it takes 52 minutes, but you get a 90-minute time limit. The review is a little longer with 28, and a little over an hour is the estimated time. So here it is, 28 questions. So we go all the way back to the beginning of chapter 1. Determine whether the type of reasoning used is inductive or deductive. Every time Beth sold back her textbooks, she got about 10% of what she paid for them. So this semester she decided not to bother selling her books back. So this is deductive when you use past information to try to predict what's going to happen next. Whoops, I guess I had that backwards. Let me see that again. Inductive is the process of reasoning that arrives at a general conclusion based... Oh yeah, see, I had that backwards. So inductive is when you use the past information and then try to predict what's going to happen next. Deductive is the process of reasoning that arrives at a conclusion based on previously accepted general statements. It's based on overall rules, not specific examples. So that's the difference. So if it's a specific example, then specific examples are inductive, not specific examples are deductive. This was one specific example that happened to her, so that's why it was inductive. So let's redo that. For the first 3 games this year, the parking lot was packed with tailgaters, so we'll have to leave extra early to find a spot this week. See, that's inductive again because we're doing this based on some examples. Some examples in the past helped me decide what to do next. That's inductive. If it's not based on examples, not just a few, like 1 or 2 or 3 examples, then it's deductive. So use inductive reasoning to find a pattern. See, we're looking at a few examples here. So if I see what happens in this handful of examples, then I can try to predict what's going to happen next. So that's exactly what those first 2 problems were like. So one thing I try for these pattern problems is, are you adding or subtracting the same amount every time? And if that doesn't work, how about multiplying or dividing? If I go from 1 to 3, you're adding 2. To go from 3 to 7, you're adding 4. To go from 7 to 13, you're adding 6. It seems to get bigger by 2 every time. So let me write this down here. 1, 3, 7. We're adding 2 first in the first example. Then we're adding 4. Then we add 6 to get 13. So by this pattern, I should add 8 next and get 21. Then add 10 and get 31. And this is inductive because I'm using previous examples to do the next one. 31, see, then add 12 and then add 14. That's as far as the pattern goes here. Add 12, 43. Add 14 is 57. So if they want one more, then that's probably the homework answer is what's the next one. So if I add 16, I'll get the next one. 57 plus 16 is 73. Or you can do 57 plus 16 is 73. So when you take your test, you can have a calculator, but it can't be like this attached to a computer. It can't be in a phone. If you're taking the test on a computer, then there's this lockdown browser that won't let you access anything else on that computer, but you can't have like another computer or a laptop or a phone nearby and look things up. So if you're going to use a calculator, it needs to be a handheld, battery-operated calculator that you would just buy in a store somewhere. And in this class, you don't need a too fancy of a calculator. Really, all you need is something that has an exponent button on it, like 2 to the 3rd power is 8. So if you get a calculator that at least has an exponent button on it, so even some cheap calculators have that. 73 would be the next one. So up by 2, up by 4, up by 2, up by 4, up by 2, up by 4. So there's a alternating pattern. So the next one should go up 2, 23 plus 2 is 25. And then you go up 4, 25 plus 4 is 29. And this is all inductive reasoning because I'm using examples to figure it out. Okay, another thing we did in chapter 1 was rounding to either a large number or to a small decimal number. This wants it rounded to the 10,000s, not thousandths, but thousand. So it's ones, tens, hundreds. The first number after the comma is thousand, and then 10,000's right there. So whatever number you stop at, everything in front of it's going to stay the same. You're definitely going to have a 1 and a 7. Then this 3 either stays 3 or gets bumped up to a 4. That's all that ever happens to that number. Since the next digit is 5 or higher, then you do add 1 to the 3 and make it a 4. And on really large numbers, like in the millions, the rounding process just creates all zeros after that. So right where the 9, the 8, the 6, and the 4 are, all 4 of those need to turn into zeros. So a 1.74 million is, this is 1.74 million or 1,740,000. I'm closer, the 739,000 is closer to 740 than it is to 730 is another way of thinking about the problem. Round this to the thousands place, so ones, tens, hundreds, thousand is right there, this first 8. So that means the 8 in front of that's going to stay the same. And then this 8 will either stay 8 or bump up to 9, but the next digit's a 2, so keep it as an 8. And now there's only 3 more numbers left, so that I need 3 zeros. 88,247 is closer to 88,000 than it is to 89,000. That's what rounding's about. You want to get to the closer, nicest number. Estimate the time it would take you to drive 158 miles at 39 miles per hour round to the nearest hour. So the idea here is that 158 is pretty close to 160. You could, and this doesn't always work, but usually if you just round it to the next convenient thing like 160, or maybe you round down to 150. Sometimes they even go that far, but I'll go the closer one first. 39 is really close to 40. And then if I multiply this, the idea is it's a little bit easier to multiply than the original number. The original number is really hard to multiply if you're not using a calculator anyway, but you could use a calculator to see this. But if there's numbers that end with zeros and you're multiplying, those zeros just go on to the end of the answer. So I can ignore these 2 zeros and just put them on the end of the answer. And then 6 times 4 is 24. 4 times 1 plus 2 is 6, so 6,400. If I were to actually do 158 times 39, it's 6,162. So at least I'm in the ballpark. It's 6,000 both ways. So it's just a rough estimate. People used to do this a lot more in the past. Now everybody has calculators everywhere they go because they're probably on your cell phone. This is kind of becoming an obsolete skill to have, but people would go to grocery stores in the era before cell phones, or before at least before they had smartphones anyway, and you would be surprised sometimes by the price at the end. But if you would keep track in your head with these simpler calculations, at least it would be close to the price that way. Now it does say, I stopped because I was reading this. It says round to the nearest mile, so maybe they want me to just do this. 6,162. But it's about estimation, so what if I do 6,400? Is that just too far away? Okay. So sometimes you don't know what they want. Just let me not do that one. Let's do example. Sometimes you have to see what they want exactly. We could round 240. See, they're rounding 239 to 240, and they're rounding 39 to 40. And, oh, maybe I went the wrong way. Divided by, I didn't read what we were doing here. You would like to drive 158 miles at 39 miles per hour. Find the time. So what I forgot here is it's distance equals rate times time. So I think they do want these rounded versions where you just use 160 for the distance and 40 for the rate or the speed. But I multiplied when we should have been dividing because I have to solve for t. I wasn't paying attention to which variables they were giving us. See, and then this is easy too because the zeros cancel out. And 16 divided by 4 is literally 4. See, I could do that all in my head without a calculator. And if you do use a calculator on the original numbers, if I would have done 158 divided by 39, 158 divided by 39, it's pretty close to 4.05. So to the nearest whole number, that's the same answer, 4. Round to the millions. So million is the first number after the second comma. If you're going right to left, the million is right where this 5 is. This is 45 million. So you're either going to put 45 or 46. It's always either 45 or 46, one or the other. This will be 45 because the next number after the 5 is a 2. And then, so then you don't add 1 to it. And then there's 1, 2, 3, 4, 5, 6 numbers after that. So I need 1, 2, 3, 4, 5, 6. 45,251,000 is closer to 45 million than 46 million. A fraternity charged $2 admission for dudes and $1 for ladies. I remember this when we did the homework. The fraternity made $80 and sold 55 tickets. How many ladies attended the party? So there's always one equation about money. They're charging $2 for males and $1 for females. So we just call whatever comes first is X and whatever comes second is Y when there's 2 of them. $2 for dudes, $1 for ladies. And then it equals $80 because you just have one equation that's all about the money. And then there's a second equation about the size of the group. So that's always X plus Y. The number of men plus the number of women equals the total size of the crowd, which is the 55 tickets. And then if we multiply one of these equations by -1 and get negative X, negative Y, and negative 55, then what happens is one of the variables cancels out. These Y's are going to cancel out because 1Y minus 1Y is 0Y. And then if you do 2X minus 1X, that is 1X. 80 minus 55 is 25. So we just discovered how many men were at the party. 25 men. Now, they sometimes ask for that, but they ask for how many ladies were at the party. So it turns out you just can't solve for that directly. You just solve for the easier one first. But now you can plug this back into either one of the 2 original equations. I would plug it into the second one because the numbers are smaller. This one's got a 2 and this one doesn't. This one's 80, this one's 55. So put the 25 right where that X is. And with some high school algebra, you just solve for Y by subtracting 25. So apparently there were 25 dudes or men and 30 women. And if you charge $2 for every guy, 25 guys times $2 each is $50. If you charge $1 for each woman, and there's 30 women, 30 times 1 is 30. And notice this is a double check. 50 plus 30, there's the $80 that they said they collected. So, you know, word problems are sometimes hard to solve because you got to set them up and solve them, and both of those can be hard. But one nice thing is if you ever get what you think is the answer to a word problem, you can always double check it. And if you happen to, if it double checks out, then you're 100% sure you did that right. There were definitely 30 ladies at the party. A small beverage company has 401 bottles of water to ship. If there are 8 bottles per case, how many cases are needed and how many bottles will be left over? So this is a division process. There are 401 bottles, and they want to put them 8 per case. So if you divide by 8, that's how many cases you're going to need. You're going to need 50.125 cases. So in other words, 50 full cases, and then there's a little bit left over. So how many cases are needed? How many bottles will be left over? So they need 50 cases. Those they'll be able to fill exactly. But there's some bottles left over. And what you can do to figure out the leftover ones is if you subtract the 50 and get rid of the 50 cases you already know is your first answer, there's a decimal amount left over that won't fill up a whole case. But if you multiply this by how many bottles are in a case, 8, that will be the how many are left over at that point. So there's 1 left over. Or another way of thinking about it is if you get 50 cases and there's 8 bottles in every case, 50 times 8 is 400, and we had 401 bottles, so yeah, there's 1 left over. Okay, here comes set theory. So now we must be in chapter 2. So the set 120, 122, 124, all the way to 132. Notice the dot, dot, dot in the middle. That means the pattern continues in the middle. So it's going up to, and then you can assume up to 126, up to 128, then up to. Usually they only put a dot, dot, dot if there's a lot of numbers missing. Especially if it's at the end. If you put dot, dot, dot at the end, that means it goes on forever. But say this was 120, 122, 124, dot, 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 150, 152, then that makes more sense to put the dot, dot, dot. Here I could have easily just wrote 126 and 128. But these are even numbers, even natural numbers. Natural means they come out exactly, but every answer says natural. So are they just natural numbers in general, like 1, 2, 3, 4? Are they odd numbers like 1, 3, 5, 7? Or are they even numbers 2, 4, 6, 8? These are evens. And remember how I missed this one? Sometimes you have to get these wrong to figure out what they want, but I would assume between includes the endpoints. Remember, they didn't include them. So 122 and 130. Apparently, their betweens are actually what some people call strictly between, and it doesn't include the beginning or the end. Oh, no, I guess that was another problem I'm thinking of. Okay, so maybe this one does want 120. I remember that happened one time, but I guess it wasn't this one. That's always the trick there. Okay, wait a minute. Numbers between 120 and 132. That's weird. Set up even natural numbers between 120. Okay, no, I know what it is. It's 118. Yeah, you have to go 2 the other way. Between 118 and 134 because those are not included. So when they say between 118 and 134, they're not including those 2. So the next number after 118 is 120, and that's where their list would actually start. And then the first even number before 134 is 132. So don't go inward 2, go outward 2. That's what I was doing wrong here. This I find kind of silly. Why can't I have 120 and 132, but why can't we have the ones at the beginning and the end? Okay, remember we did this, and I told you at the time, it doesn't even matter what's inside the set. You can have 1, 2, 3, A, B, C, 3, 5, 7, sausage, pepperoni, mushroom, it doesn't matter. If there's 3 things inside of a set, that's a cardinal number or sample size of 3. The cardinal number is 3, the size of the set is 3. All size 3 sets have 8 subsets because the number of subsets, the rule is 2 to the nth power, where n is the size of the set. 2 to the third is 8. So I figure out how many there are first, because then I can list 1 through 8 and make sure I get them all and don't leave any out or don't count any twice. You always get the empty set, which can be written that way, or with just empty squigglies, but don't do both. And as long as you're doing regular subsets, you can also always include the original one too. And then there's such a thing as proper subsets where all we do is take that one away. So there's one size 0 subset and there's one size 3 subset. There's 3 size 1s and there's 3 size 2s. The size 1s are easy. You just write each one of these once. So just the set 3, just the set 5, and just the set 7. Those are the 3 size 1s. And then if you cover up 3 and don't look at it, all you see is 5 and 7. Cover up 5 and all you'll see is 3 and 7. And then cover up 7 and you'll just see 3 and 5. And order and repeats don't matter in sets, so generally we try to write them without repeats and without them being out of order. Otherwise it could get confusing to somebody if you're trying to figure out is mine equivalent to theirs. So it's just kind of a rule of thumb. It's not completely wrong, but it's a rule of thumb. Never write repeats in sets and try to write them in order from lowest to highest. Because some people will do 3, 7, and then they'll try to do 7, 3 as another one, and that doesn't count as another one. 7, 3 is identical to 3, 7 in sets, because order doesn't matter. And then you got to worry about, do they want to know how many there are or to list them all? Here they want to know how many. There are 8 sets you can do doing any 3 items. Doesn't even matter what the items are. And then if you want me to list them, okay, I'm going to do empty set with either this or that. You can pick either one. Comma. Now I'm going to do the braces with 3. Comma. Braces with, with 5. Comma. Braces with 7. Comma. 3, comma, 5 inside the braces. Then another comma. 3, comma, 7. And 5, comma, 7. And finally, 3, 5, 7 all together. 1, 2, 3, 4, 5, 6, 7, 8. So this problem was good because it had both how many and to list them all. Okay, true or false, 2 sets A and B are equal if they have the same number of elements. That's false. That's the rule for equivalent. Equivalent have the same number, same size. Equal literally means equal. To be equal, you have to be equal in every way. You have to be totally identical, not just the same number. They will have the same number, but not just the same number. They also have to have identical inside things. So the set 3, 5, 7 that we just did a second ago, 3, 5, 7 is equivalent to 1, 2, 3, but it's not equal to 1, 2, 3. 3, 5, 7 is only equal to 3, 5, 7. And remember how order doesn't matter and repeats don't matter? So if somebody writes 3, 5, 7 is equal to 5, 3, 5, 7, 3, 5, 5. This is a true statement here, even though it doesn't look like it. Because normally equal, they better be the same size, first of all, and then they also better have the same elements. And when you write it like this, it doesn't look like they're the same size. But these really are equal because somebody is just doing something that's kind of improper. It's improper to write this out of order and to write repeats. So if you get rid of the repeats, get rid of the out of order, then you would realize, oh yeah, they are equal. That's why we don't want to do out of order and repeats, because then you can mislead yourself even into realizing something's not equal to itself. Okay, list the set of states with more than 50,000 immigrants. So more than 50,000 would be 54, 104, 130, 130. All these are more than 50,000. So it's the first 1, 2, 3, 4, 5 states from California to New Jersey. And luckily they put all these in order, so if you just start clicking them in order, California, comma, New York, Florida, Texas, and New Jersey, just put a comma between each one. List the sets of states in the top 10 with fewer than 30,000. Fewer than 30,000 goes below this 33, so it's these three right here. So it's Virginia, Georgia, Pennsylvania, the last three. Virginia, comma, Georgia, comma, Pennsylvania. List all X such that X is a state with at least 5% of the immigrant total. So that's just using this other column, the percentages. And at least 5% means 5% or higher. And there is one exactly 5, and that's included. So it's the top 5 again. New Jersey and up are all at least 5%. So California, New York, Florida, Texas, and New Jersey again. At least means greater than or equal to. X is a state between 3 and 12%. And remember this is the one where this between actually includes them, I think. That's so strange to me how sometimes it includes and sometimes it doesn't in their homework anyway. So do we even have one that's, see, there's exactly one that's 3. So between 3 and 12 would not include the 12.3, but it would include the 11.9. So it's from Florida all the way down to Massachusetts. And when I did this in the homework, I didn't think the Massachusetts would count because their other betweens didn't include the ones at the end. But this one did, if I remember right. Yeah, see? Green. Oh, no, wait, they are. Okay, maybe I misremembered it. They're saying Massachusetts, no, maybe? I could swear there was one between where they didn't follow their own rule, but this wasn't it if it was, unless I'm thinking of a different class. But okay, so yeah, see, this between does not include 3. So there is one exactly 3, but that doesn't get, their betweens somehow don't include the ones right on the dot. See, this is why we do homework first, then we do the review, and then by the time you take a test, it's your 3rd time through. And some of this has been a few weeks since we've done these, so it's easy to forget them. So this is why it's good. If you do your review, I would do it once to get a good grade on it, and then right before you take the test, you should do it again, just to refresh your memory, because even I'm missing a few things here, forgetting what their little rules are sometimes. Is 1, 2, 3, 4, ... equivalent to 2, 4, 6, 8, ... Well, it turns out they're the same size. They're clearly not equal because 1 and 3 aren't even in this one. You're only equal if you're totally identical in every way. They're definitely not totally equal. But they are equivalent because they're the same size. Every real number has an even number that matches up with it. State whether this is true or false. The empty set is not a proper subset of A, B, C. This is false because the empty set, whoops, I had the baseball scores going there. The empty set is it's a subset and a proper set of every other set. In fact, it was in this list right here. If they ask you to list or count subsets, the empty set is always there. The only time it wouldn't be is if you did a proper subset of itself. What are the proper subsets of the empty set? Well, then it's not itself, because no subset is a proper subset of itself. And this is actually the proper subset symbol. So normally the empty set is a proper subset of any other set besides itself. That would be true if they didn't have the line through it, but since they have the line through it, then it's false. That's how I always do the ones that have a line through it. Otherwise it can get confusing and you could miss it because of a double negative sometimes. The intersection of two sets is a set of all elements that are common to both. See, that's true. Intersection is when you're looking for what do they have in common. Union is when you want to grab one of everything. So it includes elements that belong to only one of the two sets. Okay, well this is false then because they messed up the second half of this. The first half of this is true. The intersection of two sets is a set of elements that are common to both, but the union is all the elements that belong to one set or the other or both. So they messed this up by saying it's only one of the two sets. That's definitely not true. Now, when I do unions, I actually write down all the answers from one of them, but that's not the full answer. Then you go to the other one and grab anything you don't have yet. So this is false. That's funny. I got right in my bottom corner here. It's giving me a, oh, it was there. It's gone now, but it was just giving me the baseball scores, and maybe it's because I went to the page where I had the baseball scores on, and I was like, oh, that's what the AI is watching me and trying to do what I'm already on, apparently. Who knows what else they're watching. But, okay, there's something's weird here. The union also, okay, wait a minute, I missed the word also maybe. The union also includes the elements that belong to only one of the two sets. I think it's the wording here. I think what they mean by this word also is that if you do all the stuff they have in common first, when you're doing, I wouldn't do it this way, but if you were doing a union and you wrote all the stuff they have in common first, and then anything that belongs to only one of them, now that's a little misleading in my point of view, because I think they mean only one at a time, not only one. This is a bad question in my opinion. Let's try another one. A subset is a set in its own right. That's true. An element of a set is just an individual member. That's true. There are a few just bad problems, and there's nothing I can do about that. We have to work with what's here, and some of them I don't even like the way they're worded, but if you try another one, then usually there's a good one. Now in a test, you don't get to try another one, but it's just kind of the luck of the draw. Hopefully you get good questions on the test. Most of them are good, but every so often you get one that I would disagree with the way they're wording that. Find the number of subsets and proper subset that this set has. Do not list them, just how many. So it's the same rule I had up here a second ago. Where'd it go? Here, this. Number of subsets is 2 to the n. And we were only doing the subsets that time, but number of subsets is 2 to the n. It turns out the number of proper subsets is always 1 less than that. You do that first and you just literally subtract 1. Because the only difference between a proper subset and a regular subset is you just don't include the one that's equal. If I go back to my list, where's my list of subsets? See how there were 8 subsets here? If you eliminate this one only, the original one, eliminate the original one, that's the only thing that's not a proper subset here. There were 8 total subsets. If I get rid of the original one, there's still 7 left. That's why it's always minus 1. So if you have a size 3 set, 2 to the third is 8 subsets, and then it's automatically 7 proper, just 1 less. Say n is 5. 2 to the 5th power turns out to be 32, and this is why it helps to have a calculator that has an exponent button. 2 raised to the 5th power is 32. Well, then there's 31 proper subsets. If you had a set of size 2, 2 squared would be 4, and then the propers would be 3, always 1 less. Well, I actually have the size 0 set. The example I got this time is the empty set. That's a size 0. So the number of subsets is 2 to the 0 power, and anything to the 0 power is 1, actually. You might not know that, but 2 raised to the 0 power doesn't, people think it equals 0, but it actually equals 1. Because every set is a subset of itself. So the empty set is a size 0, but it is a subset of itself. But nothing's a proper subset of itself. So the empty set has 1 subset, but it literally has no proper subsets. Because you just subtract 1. So one subset and no proper subsets. And if I try another, maybe the next one's got a bigger, see, this one's got a size 3. And remember, we already did 3, 5, 7, A, B, C, X, Y, Z, that doesn't matter. 2 to the third power is 8. And subtract 1, 7. That happens every time there's a size 3. Okay, C union the universal set. Well, whenever I do unions, this is why I didn't like the way that other problem was worded. When I do unions, I don't look for what do they have in common and then try to go back to each one. That would just take too long. An easier way to do union, in my opinion, is to get to the bigger sized one of these two. Whatever one's bigger, write everything in that one. All of those things that in the bigger one are going to be in the answer no matter what. And there's nothing bigger than whatever the universal set is. By rule, that's the whole thing you have to work with. So if I write every number from the universal set, all of those have to be in a union answer no matter what. Then you go to the smaller one, C, which only has 5 elements. The universal has 10, the C only has 5. So I wrote every one in the bigger one first. And then you go back to the smaller one and try to grab stuff you don't have already. Well, this is a kind of a special case because the universal set's already everything. So there's literally nothing in A, B, or C that's not already in the universal set. So neither A nor B nor C, none of them can ever contribute anything more than whatever the universal had. So you can try, but the universal's already got 12. It's already got 14. It's already got 15. It's already got 19. It's already got 20. So C's not helping it anyway. But so this is just a special case. Usually the smaller one will get you some more stuff in your union answer, but not this time. C union the universal set is literally the same thing as a universal set. Okay, true or false? A proper subset of a set B can equal the set B, but a subset cannot. See, this is backwards. That's exactly what proper subsets are all about. Proper subsets don't allow you to include the equal one. That's the only one you throw out compared to subsets. So they literally they should flip-flop these two and put subset in the front and proper subset in the back. Okay, this little n means number of elements. It's the same thing as the size or the cardinal number, cardinality. So they want to know how many elements are in B, not to list them, but how many are there. B is a prime number greater than 5, and here they've listed all the prime numbers you have to work with. So we want any number in this list right here that's greater than 5, and greater than 5 does not include 5. So don't use 2, 3, or 5, but use all the ones greater. There's 7, 11, 13. You can't see on my fingers, I guess. 13, I'm counting on my fingers. 17's 4, then 19's 5, and then 23's 6. There's 6 numbers greater. 6 prime numbers greater up to the number 24. And that's just how many there are. Okay, we got 20 down, 8 to go. So this is a good stopping point. Let me give you the last magic word of this unit. Your first test is over chapters 1 and 2. And I have a total of 5 videos counting this one. There was one video that had the introduction to the class plus 1.1, and I had a magic word in that video. Then I had a second video for 1.2 and 1.3. There was a third video for 2.1 and 2.2, and then finally a fourth video for 2.3 and 2.4, and this is the 5th video for the review. So there's a total of 5 magic words, and most people that watch my videos and send one of them send them all. So send all 5 either individually or all in one email. It doesn't bother me which way you do that. Occasionally I get somebody, they only send the first 4 and they run out of time and don't finish their homework and don't do the review, and at least they sent 4 of them, so they'll get 4 out of 5 credit and get 80%. Strangely, sometimes I get them where they don't do the first one and they give me the last 4 only, or they miss one in the middle, or sometimes they only send 2 or 3 of them and then don't send any more. And then there's always a handful of people that just, they never send any and don't watch any videos. So the final magic word, if you know what the theme so far has been in the other 4 videos, you can probably guess what type of answer is coming, although maybe you wouldn't be able to guess which one it is. because there's a whole bunch of them, but we'll go with San Antonio for the final magic word of Unit 1. There should be 5 magic words. They all follow a similar theme. And I'm sure you've heard of them all, so send them all in an email to me, or maybe you've already been sending them one at a time and now you got one more to send me. I've already received a bunch of emails from most students that are doing this. Okay, now we're up to Venn diagrams. So first of all, it could be list them or how many. This little n in front means how many. So if I cover up A, this little A apostrophe means cover up A. Don't look at this 8, 15, 13, 4, 9, or 16. Cover that up. A goes all the way around the red circle. Cover this all up with your hand. And what do you still see? You would see this 1, this 17, this 3, and you would see the 6, the 11, and the 5. Now this U doesn't count. That's just saying that's the universal set. The B and the A don't count either. So there's 1, 2, 3, 4, 5, 6 things that are literally not in circle A. And maybe I should write them down. 1 in order. 3, 5, 6. Oops, I keep coming here to the baseball scores. 1, 3, 5, 6. 1, 3, 5, 6, 11, and 17. Those 6 are not in circle A. Do the same thing for not in circle B. B is the blue circle. 16, 9, 4, 11, 5, and 6, they're all in there. If you covered all these up with your hand, you would still see this 3. You would see the 17 and the 1, plus the 8, the 15, and the 13. So in order, it'd be 1 and 3. 1 and 3. 8 and 13. 15 and 17. And they have the unions, or I'm sorry, the intersection. Intersection is what do they have in common? Well, they have 1 in common. They have 3 in common. There's only 1, 5, 1, 6, 1, 8, 1, 11, 1, 13, 1, 15, but 2 17s. So the final answer is the set 1, 3, and 17. Oh no, see, I listed them. My fault. Remember it said n, so the size of that is 3. I realized that it wasn't listing them because it wasn't giving me a chance to put a squiggly. So yeah, watch. I make little mistakes every so often, so watch out for the little mistakes, because you could have, if this wasn't a computerized test, I might have wrote the set down instead of how many. So how many elements are in B? B is the blue circle. If you go all the way around the blue circle, how many numbers are in there? 1, 2, 3, 4, 5. If they wanted me to list them, it would be 3, 5, 6, 10, and 16, but this is the number of. A union B. Remember in Venn diagrams that A intersection B is this kind of little in-between football wedge. But A union B is literally when you go all the way around both circles at the same time. All the way the outsides of both of them, that's A union B. And how many elements are in there? Well, and the letters count too. 1, 2, not this capital letter, but the little letters. 1, 2, 3, 4, 5. There's 5 things that are only in A. There's 3 that are in both. And then there's 1, 2, 3, 4, 5, 6 that are only in B. So it's 5 plus 3 is 8. 9, 10, 11, 12, 13, 14. Okay, so find the cardinality of set not A union B. A are odd natural numbers less than 12. Odd natural numbers less than 12. That's what A is. So A is literally 1, 3, 5, 7, 9, and 11. These are the odd numbers less than 12 if you're just doing natural numbers, exact numbers only. But the universal lets you go all the way to less than 24. So out of all the odd numbers less than 24, which ones do I not have yet? Not A. Not A are all the rest of them up to 24. So not A would be 13, 15, 17, 19, 21, and 23. Because less than 24 is not an odd number, so I don't have to worry about that one, but less than 24 wouldn't include it anyway. So here's not A. And then I need to do regular B. And then there's either a union or an intersection here. It's a union. B are prime numbers greater than 5, and we had that earlier a couple of problems ago. Prime numbers greater than 5 are 7, 11, 13, 17, 19, and 23, those 6 numbers. 7, 11, 13. And this is a union here. 17, 19, and 23. Well, both of these are size 6 sets. So anytime I'm doing a union, I like to write all the ones inside the bigger one. Well, if they're equal in size, you can pick either one. So I'm going to pick B just because it starts with a smaller number. So if I write every number from set B, all 6 of these have to be in the answer no matter what. Now go to the other set and grab stuff you don't have already. I already have a 13. I don't have a 15. So add that one in. I already got the 17. I already have the 19. I even have the 23, but I don't have the 21. That's how I like to do unions. Apparently they get the common stuff first, and then they go one by one to each set and grab stuff they don't have already. To me, that takes longer. It is more confusing. But apparently by that poorly worded question, that must be their process of finding a union. So there's 8 answers here. So if I'm listing them, I have to list all 8. If it's the number of elements, which I think it is, then we'll just say it's 8. Yes, number of, so 8. Oops. A union B. 8's not right. Okay, did I miss something? Prime number greater than 5. 1, 2, 3, 4, 5, 6. Yes. And then the opposite of odd numbers less than 12. Okay, yeah, I know what I did wrong. Okay, so look at the universal set. It's all natural numbers less than 24. So the universal set is actually 1 through 23. So what I did is I was doing the opposite of A. I was doing the opposite odd numbers as A, but actually it's every number except for them. There's 23 numbers from 1 to 23. A's only got 6 numbers. So not A should have 17 numbers in it, actually. It's everything except 1, 3, 5, 7, 9, and 11 all the way to 23. So this was wrong here. I already got 1, but I don't have 2. I already got 3. I don't have 4. I don't have 6. I don't have 8. I don't have 10. And then I literally don't have 12 all the way to 23. That's actually not A. It's not just I was doing just the odd numbers, but that was wrong. So not A, there's 17 numbers there. So you should write all 17 of these down, first of all. So the cardinal number is at least 17, unless B can give me some numbers I don't have already. I don't have 7, so there's one that I can add to the list. I don't have 11. but I have 12 and higher, everything 12 and higher, so all these aren't going to help. So it was the 17 numbers that were not in A plus 2 more. So the answer should be 19 actually. And that's a little bit harder to do because there's so many numbers not in A. Okay, so remember this, we got the 3-circle Venn diagram. Something you want to buy might be available on Amazon, or maybe it's on Google Books, or maybe it's on iTunes. And if you're only Google Books, you're this one. Only iTunes here, only Amazon there. If you're all three, you're in the middle. And if you're one of these three, then you're the two that touches that. So this right-hand one here, it's Google and iTunes at the same time. And usually the way these problems work is you start your way inside and go out. If they tell me the one that all three occurred at, 100 new books, 9 had an ebook on Amazon, 4 were only, okay, so there's all the individual ones. 25 total available on Google. 6 could be found on both Amazon and Google, but not on iTunes. And then, okay, so this is not the normal one. There were 25 total available on Google, so that's all 4 of these circles combined. That should add up to 25. So what we know is 100 books is a total. 9 had an ebook available on Amazon, only on Amazon. See, 9 only had Amazon. That's this right here. 9 are only on Amazon. 4 are only on Google. That's this one. And 19 are only on iTunes. That's this one. There's 25 total on Google, so that doesn't help me do anything yet because I need to know 2 more of these 3 to use that. 6 are found on both Amazon and Google, but not iTunes. 6 are on Amazon and Google, but not iTunes. That's this upper one right there. Because Amazon and Google are here, but you don't want to include the iTunes one. 5 could be found on iTunes and Google, but not Amazon, so that would be this one right here, 5. Now I can go back to this 25, the total for Google. The total for Google is 25. That's all 4 of these sections right here. And the 3 that I already have add up to 15. 15 minus 25 is 10. And then, okay, we're still missing 2 of these here. Oh, is it this here? 9 had an ebook. Oh, no, it's only on Amazon. Okay. 6 are on these. Okay, so that's weird. If you can get it down to just 1 unknown, then you subtract from 100 for the one missing one. Seems like I'm missing something here. Okay, well, let's add up what we got so far. So we've got a 9 plus a 6 plus a 4 plus the 10 plus the 5 and plus the 19. We're already at 53. And there's 100 total. So there's still 47 to go, but I can't, whoops, I typed that wrong. 100 minus 53, there's 47 to go. But these 2 add up to 47, and we need to know one of them to get the other one. 9, 4, did I skip any other number? 9, 4, 19, 20, oh, 5, this one here. Oh, that's the, I did miss one, okay. I knew we needed one more right here. This, I don't know how I didn't see that. 5 could be found on iTunes and Google, but not Amazon. So that's this one here. No, wait. Oh, I did use the 5 already. It's the 6 I think I never used. No, we did use that. Oh yeah, the 25 from Google. So, I don't know if there's a mistake here or not, or am I missing a number? 9, 4, 19. We got all three of those. The 25 is not in the graph. It's these four added together are 19, or are 25. And then there's just the 6 and the 5. I have both of those, 6 and 5. We need to know how many are on Amazon and iTunes, but not Google. That's what I think is missing here. Oh, wait, right here. Every book released was available on at least one of them. Okay, so then does that mean this is the whole 47 and this is 0? I guess that's what that must mean. Every book released was available as an ebook on at least one of these, so there's nothing that are on none of them. That's okay, that's how. So see, we know this outside number. I didn't see that last sentence was giving me a number. So by them writing this last sentence, they're telling you the outside is 0. And I knew these two had to add up to 47, but if this one's 0, then all 47 are right there, although that seems like a lot for one little section of the pie. But yeah, that's what it was. So how many books are available on all three? That's this middle portion right here, 10. The all three is always the very middle portion. How many books are on Amazon and iTunes, but not Google? See, this is what they didn't tell me, and I really wanted to know that. That was 47. But you can't solve these unless there's only one unknown. If there's two unknowns, you're kind of stuck, and that's what happened to me for a second. How many books were available in exactly 2? Exactly 2 are this 6 right here, this 5, and this 47. Those three that are in 2 circles at a time, but not all three. 47 plus 5 is 52, plus 6 is 58. So one of two ways these problems usually happen. Usually they start you with the innermost one and then you work your way out until there's one box left. Or they kind of work outside in is the other way. Out of 25 students taking a midterm psychology exam, 12 answered the first 2 bonus questions. 17 answered the second bonus question, and 1 didn't bother with either one. So the one who didn't bother with either one, that's the outside for sure. 12 answered the first of the 2 bonus questions. So that's this one here, 12. And 17 answered the second one. Nope, that can't be right. Okay. So, because there's only 25 total students. So this is 12. And this is 17. So we don't know the middle portion. 217 answered the second. So this is x plus something. This plus something equals 12, and the same something plus something is 17. Let's see, 24. There's percent too. Okay, that's weird. 25 students. Let me see an example here. What am I missing on this one? So if you add that up and subtract the total. No, that's the both. 17. Where's their problem? 50 students, 33 and 32. 33, 32. And minus the 1 from the total. Okay, so if you add 12 plus 17, that's 29. And then we know this one person didn't answer, so take the 1 away from the 25. 1 away from the 25 is 24. So there's only 24 students total left. And if you do 12 plus 17 and minus 24, that's the middle one, 5. And once you know that, then you do 12 minus 5 to get that this is only 7. And then you do 17 minus 5 to get that this is only 12. And now notice if I add every answer, 7 plus 5 is 12, plus 12 is 24, plus 1 is 25. Now I got all 25 people accounted for. So once they tell you one didn't bother with either one, that's the outside for sure. And you can subtract that from the total number of people. So there's 24 people left. If you add the two total numbers here and subtract the 24, that gives you the middle portion. It's kind of a working backwards problem. Normally you know the middle first and you work your way out, but now it's backwards. What percentage, not how many, but what percentage of students tried both questions? That's the both is this 5 right here. But it's not how many, 5, it's what percent. Percent is when you do how many divided by the total. So if I do 5 divided by the total, whoops, that's the decimal version, and percent you multiply by 100. So 20% of the class tried both of the bonus questions. What percent tried at least one? At least one means 1 or higher, so it would be the 7, the 5, and the 12 all added together, which is 24. So 24 out of 25 tried at least one. There's only one person who didn't. And then times 100, 96%. Okay, here's a 3-circle Venn diagram with math, chemistry, English. 7 people are in all 3. How many students were enrolled in all 3? Yeah, I literally predicted what the first question would be, 7. And it's not percent, it's how many. How many are in all 3 classes? It's that middlemost portion, the purple section, 7. How many were enrolled in none of the 3 courses? That would be the 20 people on the outside. How many students were enrolled in math and English but not chemistry? Math and English is normally this wedge right here that looks like a sideways football, but not chemistry. Then you take out where chemistry goes around, you take out this 7. So math and English but not chemistry is this 16 right here. How many were enrolled in math and chemistry? But see, it doesn't say but not English. This is just math and chemistry. Math and chemistry is this football shape right here, 18. Even if they're also in English, that's okay, because they would have to say but not English to eliminate these 7. So it's 11 plus 7, it's 18. How many were enrolled in math and nothing else, just math? So that doesn't mean only math. It's literally anything math goes around, even if it's other subjects too. So how many are in math? There's 9 plus 11, 20. Plus 7 is 27. 27 plus 16 is 43. If it said only math, then you would grab that upper left number, but it just says math, so then you go all the way around the circle of math. Okay, final question. People on TV can watch football or baseball or basketball, okay? So what I'm looking for is, do they tell me, here's one that they tell me right away, is that 560 watch none of these 3. That's always that outside portion. So sometimes they tell you the none, that goes on the outside. Sometimes they tell you all 3. If you know those, I always look for those ones first. I don't see the one where there's all three. Okay. Every single person who watches baseball also watches basketball. None of those people watch football. So the baseball and basketball, which is right here, this football wedge, it says none of them watch football, so that eliminates this middle part. So that'll just be whatever this is, but they didn't even have a number for that. Okay, so we have 40 who watch baseball, 840 watch basketball, 295 watch football. 95 watch basketball and football, and 560 watch none of the three. Did they tell? They didn't even tell us the total number either. Okay, so where is it? 95 watch basketball and football, which is these two right here. But we can't tell how many of the 95 are in either one of these two. Every person who watches baseball also watches basketball. So something about that's going to help us figure this one out. So if we knew the baseball and basketball, that would help because then we wouldn't add any more to the middle. But, okay. 95 watch basketball and football, and every single person who watches baseball also watches basketball. So that means there's nobody who only watches baseball. We can put a 0 here, I guess is what that means. There's still too many unknowns at this point. None of those people watch football. So these people here don't watch football, okay? $95 watch basketball and football. Every person who watches baseball also watches basketball. It doesn't include football people. So I guess this has to be the 95 then. Okay, I still have too many unknowns to be able to figure out the rest. Because these first three numbers, 40, 840, and 295, that's when you go all the way around those circles. So I need to know 3 of the 4 things, and I know 1 in this circle, and I know 1 here, but that's too many unknowns. They didn't even give us the grand total either. Okay, whenever I get stuck, I just see what's going on here. So where's their problem? Okay, so they're doing 90 people watch basketball and football. We must subtract the number who watch all 3, but we don't know that. Okay, so apparently the all 3 is a 0 too. If the all 3 is a 0 because 95 watch basketball and football, and so that has to be 0 because of that. So now we're getting a little closer. We got 2 of these 3. We need 1 more either out of these 2 or we need 1 more out of these 2, and then we can start filling things in. So what's next? There are 100 people watch basketball, football. Okay, subtract, we got that. In 1 and 7. So you need to know 1 and 7. You need to know those 2 numbers. 285 people watch football. Okay, 0 plus 0 plus 0, 100. $185. See how many zeros there are here? Okay, so because it must have to do with this statement about baseball here. Every single person who watches baseball also watches basketball. So you can't, this has to be a 0 too is what's going to help us here. Because you can't watch baseball and football only because everybody who watches baseball also watches basketball. So what's helping me finish this is there's a bunch of zeros in these. And that's why they didn't mention it up here. But as soon as you reach a point where you have 3 of the 4 in any circle, now you can finish that, because we know how many watched football. It's 295. And 2 of these are 0, so you just subtract the 95. And now you got 200 here. Okay, there are 40 who watch baseball, but they're all right here. And now I can use this 840 that watch basketball and subtract the 95 and the 40 because there's nothing there. So this is 705. This was a hard one, actually, yeah. But it's because of all these zeros is why you're able to finish this. Find the number of people surveyed. So that's when you add up every non-zero number up, even the ones on the outside. So 560 plus 705 plus 95 plus 40 plus 200. There was 1,600 people in the survey. How many people watch only football? That's this 200 right here. Only, not football, but football would be this, but only football is the 200. And the final part is how many watch only basketball? That's the 705 down here. So this problem is a little weird in 2 regards. First of all, football is much more popular than basketball, and yet they got a lot more people watching basketball here. And then it's also weird how there's so many zero sections. That normally doesn't happen, but really that needed to happen because they just don't give you enough information in the paragraph otherwise. Okay, so we now have all 28 finished. And we have now done every problem in the review, plus most of the problems in the homework. So now it's just a matter of practicing so you don't get tripped up like I was doing a couple of times there at the end. And do the review. I would do that at least twice. Do it once and get a good grade like I just did. You can always redo problems and try another even when they're right. So right before you take the exam, I would do that one more practice run of the review. And make sure you don't have any, oh, I forgot about that little detail. And then that way when you take the test, you'll get a much better score. So this is it for review video number 1.